back in time a little bit here to 1947, when Jonathan Neumann began work on what has become the blueprint for all modern computing architectures. Every computer we have today is essentially a derivative of the work that he did back then at the Institute of Advanced Studies in New Jersey. And what's interesting to me about von Neumann is that he was a mathematician. He built the computer, the maniac at the time, to essentially solve mathematical problems, to emulate and execute mathematical models. Models of reality that could be as profound as trying to simulate global climate change, or as simple as the slider on your iPhone. Programs are really the symbolic logic of mathematical models. They are mathematical symbols adding in mathematical logic. And that's what we've been doing with computers for the last 67 years. We've been executing mathematical models, and they've served us well. We've done a lot with them. We've advanced society. We've solved a lot of business problems and social problems, and we're now applying it to solve even bigger problems, especially in the big data space. But the one thing that computers have never really been able to do well is simulate human behavior. And this is important, because there's a whole spectrum of problems out there that if we could get the computer to behave more like a human, understand humans in human terms, in terms of our language, in terms of our sources of styles of reasoning, then there's applications for the computer in ways that we've never really even imagined. If you go back to the beginning of the 20th century, Ludwig Wittgenstein said, "The limits of my language are the limits of my mind. Everything that I know is what I know in words." There's a lot of truth to this. Language is a very important element to our human behavior, to our human ability to understand, our human ability to reason, our ability to communicate ideas and concepts and to reason about what we do. And so we felt like it was important to try to address the problem of simulating human language and understanding human language well enough to be able to not only understand questions, but to even read all the massive amounts of literature that's out there that represents the totality of human knowledge as captured in our language. And so that's essentially what we did. And I know that some of you probably know about the work that we did with Ivan Watson, playing the game of Jeopardy. Right? But the Jeopardy program and the challenge that we took on there was not about the publicity stunt of Jeopardy. It was really about proving that we could break through so the limitations that have largely held us back in the world of artificial intelligence and our ability to really kind of understand language and make use of it. Right? And when we realized that a big part of what had been holding us back was, in fact, exactly what created the computer to begin with, which is essentially trying to treat artificial intelligence like a mathematical problem, right? Simulating human behavior with mathematical precision. When we realized that that was actually a limitation, that you couldn't ever come up with enough rules, right, or concept relationships and ontologies to really represent the human experience, but rather to kind of think about it more as a probabilistic problem. That turned out to be a major breakthrough for us, and we were able to elevate what is largely considered to be sort of the norm of a class of artificial intelligence, sitting around somewhere between 25 and 35% accuracy, to the levels that were necessary in order to be proficient in the game of Jeopardy and be able to consume information well enough to be able to respond to that in a situation where questions were full of idioms and subtleties and idiosyncrasies, concepts and metaphors, and the very same kinds of stuff that we see in our own everyday interactions. That's the challenge that we took on. That's what we wanted to overcome. That's what we wanted people to prove. And so since then, we've been taking what we've learned from having played that game, having built the system to understand language well enough to be able to consume 200 million pages of information that we derive from the internet and other sources, reading it essentially just like a human would in terms of identifying and understanding what it's saying and being able to use that and quickly find answers. And now we've been applying it in the areas of healthcare, in the areas of consumer service, customer service, and some other areas that demonstrate the potential for the computing system to augment our human creativity. I'm going to go back to healthcare for a moment. We've been working in a couple of different areas of healthcare. One of them we refer to as utilization management or pre-treatment authorization. And this is the situation that you run into if you ever go to the doctor and get prescribed an unusual or expensive treatment. That treatment, in order to be paid for by the insurance companies, often has to be pre-authorized. So you have to send in, the doctor's office has to send in sort of a summary of you as a patient, your disease, and the treatment that they want to prescribe. And there are literally armies of nurses and doctors at insurance companies who receive these requests every day, do nothing but go through them, understand the patient summary, reading that paragraph or two that summarizes who the patient is, reading the standard of care practices, reading the policy, right, and determining whether the treatment that's being recommended really does fit within the guidelines and the approval requirements for treatment, right? And then makes a determination. And so we felt like that since there was so much being read in that case, right, that this is an area that WASA could help with. And so we are in the process now of building a system that is reading these patient summaries, is reading the standard of care practices and the policy information, and making predetermination as to whether the requested treatment should be approved or not. Another area is in the area of oncology treatment options, right? And by the way, I should say, when we got into the healthcare industry, it wasn't just because we thought that was a great idea and it'd be great to participate in this sort of socially beneficial element of life, but it was the doctors that came to us. It was the doctors who realized that they don't have time to read all the material that's being produced out there in the healthcare industry. They don't have time to keep up with it all. And even if they could, they don't necessarily know everything they need in order to be able to apply that appropriately to personalizing treatment for individual patients. Because as it turns out, all of us are a little bit different. And how we respond to different treatment recommendations varies. So by being able to read the patient information, literally the pages of clinical literature, the clinical notes that have been written about this patient and their history, et cetera, right? Be able to do the patient similarity analytics by looking at 1 million, 10 million other patients to find the microsegmentation of the 10 other patients that are just like you, not just based on your age and race and sex, but rather based on the 5,000, 10,000, 50,000 other variables, right, that matter to determining whether you are the same as these 10 other people, whether you have the same family history and disease history and history of pharmacology and environmental experiences, et cetera, that would influence how you respond to different treatments. And then by looking at the standard of care practices and the clinical expertise, the 10 or 50 other doctors who are at the top of their game, right, and know how to respond to these different situations, and adding to that, a search through the clinical literature to find supporting evidence that reinforces the rationale behind different treatments and being able to provide that to the doctor at the point of care, that makes a difference. It enables the doctor to not only understand what the potential treatment alternatives are, but in fact also understand how you might respond to the adverse events, right, the side effects that may occur in the treatment, so they're prepared to handle that as well. Because in many cases, these side effects are as detrimental as the disease itself, but if you can handle them, right, a lot of treatments out there that have these kinds of side effects or potential side effects, in fact, turn out to be much more effective. In the consumer service support area, understanding that people have questions. Consumers have questions, not only about your products and services and support, but in fact the context in which they're thinking about buying these products. And today, their choices essentially are to go talk to a person or read a forum or read through massive amount of information. And so if we could offer answers to the questions they have, not only do they turn out to be more loyal to use an institution, but in fact you can engage them in areas of concern that they have that bring them to you looking at your services and products in a different light. And then recently we did an experiment, a demonstration that we call cognitive cooking, where we went out and read about 35,000 different recipes, and from that learned something about what a recipe type is, what different cuisines are like, right? And then we infuse that with the chemistry of taste, right? The science of the culinary arts, understanding what chemicals different ingredients present that have a taste to us as humans, and what combinations of chemicals are delightful versus not, right? And by looking at the literally 6 quintillion permutations of ingredients, we were able to come up with recipes that were truly unique. And working with the Institute of Culinary Education out of New York, we came out with recipes that they were able to produce, were able to prepare, and they were absolutely delightful. They were recipes that these chefs would have never considered, right? Because I literally don't have time to look at all the permutations. I don't have time to consider the 6 quintillion different things that might be useful, right? Narrowed down to those few within that actually are delightful in tasting. And so in summary, what we're seeing with these cognitive systems is not just simply our ability to ask and answer questions, and not just simply founded on the idea that language is important to be able to reason about that, but rather to extend our human creative processes, right? To essentially amplify our human creativity, to give it strength in ways that computing systems have never been able to do. Right? This is what we believe is the future of cognitive computing. This is the utility that we believe cognitive computing brings to our table. Right? This is where we're not only investing in advancing technology, but applying the technology to solving business and social problems. Thank you.